Hello everyone, my name is Ihsan Yassin. I'm the co-author of this paper entitled Error Corrective Output Coding SVM Classification of Coffee Roasting Levels based on MNDT as parameters. The outline of my presentation today is first I'll talk about some introductory remarks, followed by a summary of the literature review. This will be followed by the methodology, the results and discussion, conclusion, and future work. Coffee is a beverage commonly consumed around the world. It's prepared by brewing roasted coffee beans, and the coffee beans are obtained from the seeds of the berries certain coffee genus flowering plants. During preparation, after removing the coffee seeds, it is roasted to provide its distinctive flavor enjoyed all around the world. Basically, the roasted coffee beans are grinded and steeped in hot water, and after filtering, it will produce the brew. It has black hue and bitter and slightly acidic taste. The roasting process determines the fat and protein contents of the coffee bean, and this is a precursor to the flavor and the aroma of the coffee. What we are doing in this research is basically trying to discover an intelligent method for differentiating between different coffee roast levels using microwave non-destructive testing, or what we call MNDT. The MNDT equipment collects what we call S parameter readings from the coffee beans. And from our research, we discovered that the S parameters are useful as features for distinguishing several types of coffee, which are dark, medium, and light roasts. So after the MNDT testing, what we did was we fed the features around 6,400 features per sample into a multi-class SVM. This is quite common actually. The error correcting output coding ECOC SVM is capable of multi-class classification as opposed to normal SVM, which is able to perform binary classification. So, short summary of the literature review. You can read the full literature review from the paper. It seems that most microwave techniques in coffee production and processing involve using microwaves to dry and extract the valuable compounds inside the coffee beans. We also discovered several applications of microwave, such as disease detection in coffee plants. Research on using MNDT for classifying roast levels are relatively limited. We actually did wrote another paper about this, where we tested the S parameters from the MNDT testing. And we classified the coffee roast levels using multi-layer perceptron neural networks. Multi-layer perceptron neural network. So I can say that the research on MNDT for classifying roast levels are relatively limited compared to other applications of microwave in this area. This is what the MNDT device looks like. Basically, it has a transmitter and also a receiver. And we put a sample inside in between those two. Usually, we prepare we put the sample in a perspex casing, and we beam microwaves from the transmitter, and the receiver picks up the S parameter, the readings from the from through when the transmitter beams the microwaves, it goes through the sample and it gets picked up by the receiver. And from here, we can obtain S parameters. Usually, what we do is we obtain we extract or we try to calculate several parameters such as permittivity. However, in our case, we discovered that when we put the S parameters directly into the SVM, it had certain unique features that can distinguish between the roast levels of the coffee. And this is a bit more about the MNDT. A bit more of the specification. You can see from the last paragraph on our specification and the device used. So for the data collection, 3 batches of 15-day-old coffee samples were evaluated with differing levels of roast. First is light roast, medium roast, and dark roast. We obtained the coffee from Starbucks and also Coffee Bean. 3 types of samples: Cafe Verona, Colombia, and Ethiopia. The beans used were almost all Arabica beans. Each sample that we tested generated 200 measurements, and this results in 600 data points, 600 samples, 600 data points. After randomization, 70% of the obtained data was utilized as a training set, while 30% was used for the testing set. Normally, this 30% is divided into 50% validation and 15% testing. However, in Ecoc-Svm, it doesn't use the typical validation set because the classifier works in such a way that it is automatically trained. The training is automatically optimized. Each sample has approximately 6,400 S parameters. So you can imagine that each sample produces a lot of data points that needs to be classified by the Ecoc-Svm. What we found was that the classification results was very good. We obtained both 100% accuracy in both training and testing sets. This indicates that the MNDT, the S parameters from the MNDT testing were very different for each and every roast level. And from our previous research using multi-layer perceptron neural network, we also obtained the same results. From that previous test, we divided the data set to 70, 15, 15%, and it still managed to obtain 100% accuracy. So it seems that the coffee beans, coffee roast levels can be easily distinguished using any type of intelligent classifier, such as SVM or MLP. In conclusion, we have demonstrated the ability of the Ecoc-Svm to classify different types of coffee roasts. The Ecoc-Svm could identify between the various roasts, even though with a lot of sample data points per sample. We are currently investigating methods to determine coffee oxidation levels using MDT as well. Um, the work that we are doing now is we are testing a batch of the same coffee at different time intervals to see whether the oxidation of the beans can be captured using MDT. So I hope the experiment. I think the experiment will work because the oxidation level uh, will cause, I think, some changes on the S parameter readings, and probably it will have different values. Let's say for day 0, we have certain MDT readings, and for day 15, day 30, we should expect some changes in the S parameter values of the coffee of the MDT test. So thank you very much. If you have any questions or interesting collaboration opportunities, please email me at ehsan.yasin@gmail.com. Thank you very much. Thank you very much. I hope you have enjoyed my presentation, and goodbye.